Hello my dear students, let us see one more example based on linear upon root quadratic. Now this is the question right in front of us. Integral of root x minus 5 upon x minus 7 dx. Now some of you may wonder that I just said some seconds back that it is linear upon root quadratic. There is no linear expression which is outside the square root. There is no quadratic in the sum. Then how did I mention that? This is a special sum, this is a special case of linear upon root quadratic. Let us see the solution. Let us copy the question first. Now my dear students, it's a tricky one where the integral is not directly expressed in the required form. We have to express it in the form of linear upon root quadratic. Now to do that, it's clear that I need to rationalize the numerator. So I'll have x minus 5 upon x minus 7 as it is. And if you are thinking to rationalize the numerator, I need to multiply by x plus 5, then you are grossly wrong. It should be multiplied divided by x minus 5 only in the numerator and denominator. Obviously dx will follow. So in the next step now, I can write it as integral of x minus 5 upon root of. Now x minus 7 into x minus 5, anybody's cup of tea, that's x square minus 12x plus 35, and dx is also there. Now you may check, my dear students, this is of the type linear upon root quadratic. Very much for your reference, I have put the screenshot here. Now let us see, or we already know, but let us solve this. Now to solve this, we assume or we make a assumption that px plus q is a times derivative of the quadratic plus b. So x minus 5 will be a times derivative of x square minus 12x plus 35 and a plus b. That is, x minus 5 will be equal to a into 2x minus 12 plus b. Is that okay? Now our job is to find the value of a and b. So let's compare. X minus 5 is 2a into x minus 12a plus b. So if I equate the coefficients of x, that is 2a will be equal to 1. So if 2a is 1, can I say a is equal to half? Correct? Likewise, minus 12a plus b will be equal to minus 5. So we can say that minus 12 into half plus b is equal to minus 5, or we can say that b is nothing but 1. So we've got the value of a, we've got the value of b. So let us write x minus 5 is half of 2x minus 12 plus 1. Is that okay, my dear students? Now we have to use this value in the integral. What is our integral? The integral is x minus 5 upon root of x square minus 12x plus 35. So in place of x minus 5, now we will write half of 2x minus 12 plus 1. So let us do that. So that is equal to half of 2x minus 12 plus 1 upon root of x square minus 12x plus 35 dx. Now my dear students, what we can do after this is separate the terms here, separate the numerator. So we'll get half integral of 2x minus 12 upon root of x square minus of 12x plus of 35 plus 1 upon root of x square minus 12x plus 35 dx. Now my dear students, we already have seen in the earlier module, the first integral is of the type f dash x upon root f of x. So the answer will be 2 times root of x square minus 12x plus 35, and this second integral which I have here we will solve separately. So we'll write it as plus I1 and plus C1. Can we say that 2 will cancel out here? So we'll get root of x square minus 12x plus 35 plus I1 plus C1. Now my job here is to find the value of I1. So let us write I1 is equal to integral 1 upon root over x square minus 12x plus 35 dx. Now already the coefficient of x square is 1. So let me just write in the next step 1 upon root of x square minus 12x plus 35, and let's fill in the blanks. Half of minus 12 the whole square, that is minus 6 the whole square, that is nothing but 36. So add subtract 36. So if we add subtract 36. So in the next step we can write integral 1 upon root of can I say x square minus 12x plus 36 can be written as x minus 6 the whole square. So let us write here x minus 6 the whole square, and 35 minus 36 is minus 1. So we write it as minus of 1 the whole square dx is there. Now my dear students, this integral is of the form 1 upon root of x square minus a square. So log mod of x plus root of x square minus a square. That's the answer. Let's apply the formula. So it will be log mod of x minus 6 plus root of x minus 6 the whole square minus 1 square plus c2. Now this I need to simplify. So log mod of x minus 6 plus, if I simplify the function inside the square root, it will be x square minus 12x plus 35 plus e2. I1 is done. We already know the value of I in terms of I1. So let us substitute. We have the value of I as root of x square minus 12x plus 35 plus I1. So here in this case, we will substitute the value of I1. So it is root of x square minus 12x plus 35 plus log mod of x minus 6 plus root of x square minus 12x plus 35 plus of c. What is c? C is nothing but c1 plus c2, and that's your final answer. That's the set of a special sum here, and for your practice, these are the two questions which you should solve on the same lines. In both these, you are supposed to rationalize the numerator and proceed as we have seen in this particular example. That's all we have in this module. Thank you very much.